All right, guys, so here is our first recorded lesson. Hopefully it'll be okay. Hopefully you guys will be able to understand it well enough, but it's got to be better than nothing, right? So chapter 5, we're talking about quadratics. Just so that you guys know, there will be a factoring lesson after 5.2, so we'll do 5.1, 5.2 here, and then I will do a separate lesson to review factoring with you. You guys did factoring in 8th grade, but I just want to make sure that your, skills are good and up to par and all that jazz so that it doesn't, hinder your ability to work with quadratics. So a quadratic function is just a second degree function. Remember we talked about types of functions previously, and so that second degree is just pointing out to you that the largest exponent is 2. The general equation y equals ax squared plus bx plus c, where a, b, and c are constants and a is not 0. We also call this standard form of a quadratic, which is different. There's two other forms, two vertex, which we're going to talk about in this lesson, and also intercept form. Now, this part may seem random. A can't be 0, but what happens if a is 0? Well, let's think about it. If I have 0x squared plus bx plus c, you'll see that this term is 0. So you really end up with a linear, so it's not a quadratic at all. For these two pieces, these are helpful, particularly if you're graphing. So if you look at y equals ax squared plus 0x plus c, that c actually represents the y-intercept of your graph. So, oops, sorry, that's not supposed to be a plus, it's supposed to be an equals. And so if you were graphing this, your vertex, which we'll talk a little bit more, or your max or min point, is going to start at C on the y-axis. Now, if my C is 0, well, if I just said that my C was my y-intercept, then if my y-intercept is 0, that means that my vertex for this guy is at the origin. Now, when we're talking about the vocabulary here, I just really clarify for you just so that you're using your terms correctly. A quadratic equation is one that is a second degree function, and the parabolic graph is the graph of a quadratic equation. So you can't use those terms interchangeably. So if I said to you on a test, what type of function is this? And you said it's a parabola, that's wrong. A parabola is the name of the graph. It's not the type of function. What's significant about a parabola? Well, a parabola is going to have either a minimum or a maximum point, depending on some of the features of the function itself. That point is the vertex. Also, you'll notice that your graph changes direction. So my y's are getting smaller, smaller, smaller. We say that my function is decreasing until it hits the minimum, and then it's increasing. If your graph is reflected and so it's opening down, then you're looking at a function that's increasing. Its y values are increasing until you hit the max, and then decreasing. Another feature is that we have an axis of symmetry, and that axis of symmetry passes right there through that vertex. And so if you think about symmetry, think about geometry, think about, elementary school when you're drawing hearts and butterflies. If you folded this graph over, these points would match up perfectly on either side. So those points are equidistant from the axis of symmetry. The axis of symmetry always passes through the vertex. Completing the square. Why do we talk about completing the square? Not to torture you, although some of you will believe that is the case, but really we do it because it makes it easier to identify the vertex of this quadratic, and then when we're graphing, we have sort of that max-min point to start with. How do we complete the square? Well, obviously we want to get it into this form. Well, I shouldn't say obviously. We want to get it into this form. And so the way that we do that is pretty simple. Once you practice it a few times, my guess is you'll have it down pat. This c value, what you're going to do is you're going to subtract c from both sides. So I'm going to do -2 on the right, -2 on the left. y minus 2 equals x squared minus 6x. Now, something to note is that if you use a different textbook or worksheets or something like that, you may also see your vertex form written this way. And so it really doesn't matter. It's not like one way is better than the other way. It's just sort of the way that your textbook or your worksheet or your teacher or whatever it is presents this to you. All right, so my next step in completing the square is to add to both sides, and this is random, but it is going to help us. You're going to add to both sides b divided by 2 squared. Now remember, because we're working with an equation and we have an equal sign, whatever I do to one side of the equal sign, I have to do to the other. So even though some of you may be thinking you can't just add random stuff to an equation, well, you can as long as you do it to both sides. So now for this situation, my b value is -6. So on the left, I'm adding -6 over 2 squared, and on the right, I'm adding -6 over 2 squared. So I have on the left y plus 7, -6 over 2 is -3 squared is 9, minus 2 is 7, and then I have x squared minus 6x, and then plus 9 on the right. Yes, on the right. So now that still doesn't look like this, right? Okay, so what I need to do is factor that x squared minus 6x plus 9. So let me just talk quickly about, I don't know what just happened with that page. A perfect square trinomial. So a perfect square trinomial basically is a trinomial that results in, or results from multiplying a binomial, or squaring a binomial rather. X plus y squared. That would be x squared plus 2xy plus y squared. So you'll notice a couple things here. You'll notice that x squared, if you take the square root, I get, hey, x. Y squared, if I take the square root, I get y. So if your first term and your last term are perfect squares, that's an indication that you may have a perfect square trinomial. Your next step would be to... Okay, I just pressed pause and I have no idea what I just said last. So the first term, square rooted. Last term, square rooted is what you get as your first two terms in your binomial. And then if you notice, if you multiply the x and the y and double it, that's where that middle term comes from. So if you look at what we have x squared minus 6x plus 9. So let's work backwards. So the square root of x squared is x. The square root of 9 is 3. Now here's my issue. If I make this a plus, when I do x times 3 and I double it, I get positive 6x. So we know that can't work for us. So instead of a plus 3, I'm going to put a minus 3 here. Now if you wanted to check that out, x squared, good. So the square root of x squared is x. Square root of 9 is 3. X times -3 is -3x. And then if we double it, there's my -6x. So hopefully that makes sense. So now, what does that do for me is that I can rewrite now this as y plus 7 equals x minus 3 squared. Okay, so cool. What good is that? Well, the h and the k represent the vertex of the parabola. So for this particular situation, my vertex is, my vertex is going to be 3, -7. Yay! All right, so let's take a look at this second one here. Sorry, moving stuff around. It's not going where I want it to go. Okay. So now if I take a look at my second one, I have y equals x squared plus 10x plus 2. So remember, my first step is to get rid of that c and subtract from both sides. So y minus 2 equals x squared plus 10x. So now my next step is to add b divided by 2 squared to both sides. So on the right, I'm going to add 10 divided by 2 squared. And on the left, I'm going to add 10 divided by 2 squared. So my right is going to be y. So 10 divided by 2 is 5, squared is 25, minus 2, so I get 23. And then on my right, I have x squared plus 10x plus 25. Y plus 23 equals, and then over here I have x plus 5 squared. And so some of you may say, well, does it always work out that it's a binomial squared? Yes, that's the whole point of completing the square, is that you are performing a few different steps or tasks so that you have a perfect square trinomial on one side of the equal sign. That should always happen. Now, of course, I can't just make it that easy for you. So if you look at my next set of slides here, y equals 3x squared minus 24x plus 17. So the steps don't change. We still are subtracting c from both sides. So y minus 17 equals 3x squared minus 24x. Here's the difference. I can't just add b divided by 2 squared to both sides. What I need to do first on this right-hand side is factor out a GCF. Now, when I add to the right, now I'm going to add negative 8 divided by 2 squared. But here's the thing. See this 3 out here? When I add this 16 to the right-hand side, I'm really adding 3 times that. So on the left, I'm going to do y minus 17 plus 3 times 16. And on the right, 3 times x squared minus 8x plus 16. So my right-hand side is going to be, what's that? Oops, sorry, that's not an equal sign. So 48 minus 17 plus 31. And then on the right, this factors to x minus 4 squared. So my vertex, if anyone's asking, is at 4, negative 31. All right, one more for the fun of it on the right. So same thing, subtract 1 from both sides. Y minus 1 equals negative 5 x squared minus 25x. So I am going to factor out my greatest common factor on the right. I'm left with x squared plus 5x. So now keep in mind what we have to do here. We're going to have to cut b in half, so b divided by 2 and square it. 5 divided by 2 is 5 halves. So when I add that to the right-hand side, what I'd like you to do, just because this really is going to help you, is to add it as a fraction. So now keep in mind what I added. I didn't just add 25 fourths, I added negative 5 times that. So on the left-hand side, you're adding negative 5 times 25 fourths. Oops, that should be a plus here. So that is negative 125 over 4 minus, so y minus 129 fourths. Check my math, considering it's 12:33 and I'm a little bit sleepy. So hopefully that's right. If it is, then that means that my vertex is negative 5 halves, comma, positive 129 fourths. Just a side note for you, just so that you guys are aware, when you are looking at your vertex, the form is y minus k, a x minus h squared. Your vertex is at hk. So if you have x minus or sorry, x plus 4 squared, say, that had to have been x minus negative 4. Since the equation itself is a minus, you have to consider what would my h value have to be so that I have a minus in that parentheses. So in case you're wondering why I'm taking opposites, that's why. All right, just a couple quick sketches. So my vertex is at 1, 4. So if that's the case, I'm going to do a quick sketch. 1, 1, 2, 3, 4. There's my vertex. My y-intercept is at 6, 1, 2. Now remember what I said, your axis of symmetry is going to go through that vertex point. So what that means is that the y-intercept is going to have a mirror image point on the other side. So when I ask you for the symmetric point, what I'm saying is, what is that mirror image? Well, if the vertex is at 0, 6, then the symmetric point is going to be at 2, 6. And there we have my sketch. Now if you take a look at B, this is why we do my vertex form, this is why we complete the square. I'm going to complete the square here. Oopsie. Y minus 11 equals x squared plus 6x. So I'm going to have y minus 2 equals x squared plus 6x plus 9. Y minus 2 equals x plus 3 squared. So my vertex is going to be at negative 3, 2. Now your y-intercept occurs when x is 0. So if that's the case, if I sub in 0 for x, oops, then my y-intercept is going to be at 0, 11. So now remember that your y-intercept is going to have that mirror image point. So if my vertex is at negative 3, 2, then my symmetric point, hold on, let me just scroll a little so you can actually see here. Negative 3, 2. We'll just call this 11. So here's my axis of symmetry. Now it's 3 units to the right and then 9 up. So we're going to go 3 to the left and then the same spot on the y-axis. So my symmetric point is going to be at negative 6, 11. So hopefully that makes sense. Let's take a look at these last two, and then you will have homework on this. Answers are all attached to this and whatnot. But, you know, feel free to help each other out too. I'm sure some of you probably get this no problem, and others of you may be a little bit confused. So the downside to not having someone in front of you, you can't ask questions as you go. So use each other as a resource. So if I look at C, y plus 11 is 4. And I'm just going to skip right to this step for my own self because... oops, 9 fourths, and then plus 9. So 3 divided by 2 squared would be 9 fourths. Yes, okay. And then when I distribute that 4, that's where that 9 comes from. So y plus 20, 4, x plus 3 halves squared. So my vertex is at the point negative 3 halves, negative 20. My y-intercept is going to be right here, this c value. And so you're looking at a y-intercept of 0, negative 11. So my symmetric point is going to be equidistant. So if my vertex is negative 3 halves, and if you go another negative 3 halves or another 3 halves to the right, you're at negative 3, negative 11. So my sketch, we'll call this negative 11. negative 1, 2, 3. So 1.5, negative 20 we'll say is down here, and then here would be my other point. Now obviously if you have graph paper and all that jazz, you're going to do this a little bit more neatly, but I'm doing the best I can. All right, last one, D. So what I'm going to do, subtract 1 from both sides, y minus 1, negative. I'm going to factor out that negative, so it's still going to be factor out the GCF. It's just that now that GCF is a negative 1. So this would be negative a half squared, so plus 1/4. So that would be minus 1/4. Right, 1 over 2 is 1/2 squared. Yep, okay, just making sure. Y minus 5/4 negative x minus 1/2 squared. So my vertex is at 1/2, 5/4. Here's my y-intercept at 0, 1. So now if you look at the sketch of this, you'll notice something. Hopefully you'll notice something. So I have 1, 2, 3. 1, 2, 3, 1, 2, 3. Okay, so 1/2, 5/4 is here. And then your y-intercept is at 0, 1. And now remember, here's your line of symmetry. So your symmetric point is actually going to be over here. And so when you connect those, your graph's opening down. What makes it do that? It's this negative here. So when your A is negative, your graph's actually opening down instead of opening up. So that's something to keep in mind and add to your notes. So my symmetric point would be at 1, 5/4. All right, here is your homework for this section. There's also skills practice available on the drive as well, so keep that in mind that there are resources for you on there, so please make sure you use them, use one another, make sure that you're not just sitting back confused. You have some great resources and you have some great minds in that class, so if you work together, you guys will be good to go. Your next lesson is going to be the factoring after 5.2 lesson, and I will toss that on there tomorrow. Have a good day. Bye.